everybody. I'm so excited to have Matthew from the Made for Math team here with me today. We're going to be talking all about accommodations, but Matthew's got a lot of experience with kids with dyslexia, and he's been trained in Marilyn Zecker's method. And he and I have been working on a special project this year all about accommodations, which we'll talk a little bit about. But we first just wanted to welcome you in, Matthew, and then we'll jump right into explaining what accommodations are.
Hey, everybody.
Matthew, you are a delight to have around. I'm so glad you came to join me to chat about this. So
Thanks, Adrianne. You are too.
So our first question of the day is basically, what are accommodations?
Yeah. Well, accommodations are pretty much adjustments that can be made to your child's learning plan through an IEP or 504. And they come in two broader ideas. We have the output accommodation. So these are, being able to use the calculator or getting extra time or extended time on tests, getting copies of teachers' notes. So those would be examples of output accommodations. And then we have input accommodations. So that would adjust how information is learned, such as manipulative use. And we'll get into some of that today. Focus facts, or what we call near point references.
Yeah. And I like this output input phraseology. It comes from Marilyn Zecker. She and I were talking about that recently, about how a lot of accommodations are mostly heavily focused on that output. But if we can change how we're inputting things, it's really a game changer for students. And so just a reminder to those listening, you can go and listen to that conversation I had with Marilyn, where we talk a little bit about input accommodations. But we didn't go too deep because I knew we were going to be having this conversation. So input accommodations also are broken down into smaller categories that are targeting specific parts of learning in the brain. So we have that procedural, the step-by-step parts of mathematics, the verbal, the language, the math fact retrieval, and then the semantic, the know-how of mathematics. Math anxiety as well, which again, go check out Cara Scanlon's episode all about math anxiety. And then attentional support. We know that attention's a big game player in learning mathematics. So those are the smaller categories that a lot of accommodations can be nested in and underneath. But today, just to keep it shorter and more focused, we're going to focus on showing you a few procedural ones, verbal and semantic. So Matthew, let's jump into the procedural kind. Procedural accommodations are focused on supporting the student's ability to count, sequence numbers, or apply mathematical procedures. And we came up with a few to show you. Do you want to pick one and
here we
show
go.
them?
Absolutely. Okay, so the first procedural accommodation we have is to circle operation signs. So in the example of addition problem, we have 26 plus 12. A simple accommodation here is to circle the sign, follow the line, and start here. So circle the sign, follow the line, start here in the ones place. And then we'll add the ones and then add the tens. So that accommodation is circling the sign so our students don't forget whether they're adding or subtracting or multiplying. So circle the sign, follow the line, start here. And another one is for long division. We create these buttons along the side of our whiteboard, and these serve as near point references as students do long division. So this is divide, multiply, subtract, check. Oh, I gotta pause. My dogs are barking.
Totally fine.
Okay. Let me see. Maybe I should bring them in.
Okay. I'll
right,
pause the recording.
All little coworkers.
No problem. I was thinking we'll just start right over right there at division.
Okay. All right. Tell me when you're ready.
Ready.
Another place where we use procedural accommodations is with long division. Now what we do is we create these buttons on the side of our whiteboards, divide, multiply, subtract, check, and bring it down. And so when we have a long division problem, we'll just go with, let's say 831 divided by 2. So I like to call this two-handed division. Encourage my students to use both of their hands while doing this problem. And so they'll take their pointer finger and they'll touch the division button and say divide. And so do 8 divided by 2 is 4. Go down to the next button, multiply. 4 times 2 is 8. The finger stays on the button till the next one. Subtract. 8 minus 8 is 0. Check. Can I make any more groups of 2 out of 0? I cannot. So if we can drop, go ahead and do that. Rewrite. 3 divided by 2. Here we are back at the top. 2 will go into 3 one time. Multiply. 1 times 2 is 2. Subtract. 3 minus 2 is 1. Check. Can I make any more groups of 2 out of 1? I cannot. Drop the 1, and we could keep on going. And so what this does is it keeps the procedure right here, where many students can get lost in long division problems. We have the buttons right here to remind us, and we're using both hands too. So we're keeping the body active as well as we go. So there you go.
I love that. And I think the language is really key there as well, because we're talking about groups of, you use that very specific language instead of saying goes into, which I think every teacher's,
right.
Probably said that.
Goes
the
into.
Phrase we want to like get rid of from our language, but it's not as helpful to a student. Goes into isn't a mathematical phrase, but groups of, how many groups of 2 can I make, is much more helpful to a student. So not only are we've got that procedural checklist, but we've got this really good explicit language going on. So another one that we wanted to share really quick is about PEMDAS, which I think a lot of parents have heard of PEMDAS. PEMDAS is order of operations for, what order are we doing things in with those things. And so in this graphic organizer, you can see here that we start with parentheses. And you might be hearing some teachers doing GEMDAS or GEMDAS with a G for grouping symbols, but this would be anything with a parenthesis or a brace here, and then we do exponents next. Multiply and divide from left to right. And we also have an animated one that shows that the D and the M can flip. So it doesn't matter who comes first, if it's division or multiplication first, but what matters is going from left to right in our problem solving, and then adding and subtracting last from left to right. And so these kinds of things help students organize their thinking. And also it's easy enough to remember visually. They could jot this down on a piece of paper if they're getting ready for a test and they have this near point visual now, and they can use that finger, like Matthew was talking about, to help guide them as they're solving these order of operation type problems. So those were just a few of the procedural kind that we had. But let's talk about the verbal kind next. So verbal accommodations are focused on supporting math fact retrieval. A lot of kids who have dyslexia also have problems with math fact retrieval. And then also the language or the linguistic side of mathematics. So one that we thought of right away was focus facts. And describing focus facts kind of is a strange thing for us to, we were trying to decide, like, how can you encompass this? But it's basically narrowing what facts you're working on in your math practice or in your math lesson. And you could do this on a per student basis, or if you were in a classroom, but also in our lessons where you know what focus facts we're working on. So for example, instead of using all of the 7s times tables, we narrow it down. And while the students learning and mastering them might be just 7 times up to 3, 7 times 3 or 7 times 4. We try not to do more than 3 or 4 at a time, but we're using it in the warm up we're using it throughout the lesson, anytime they're learning something new, so that their mind is not fixed on trying to remember what something like 9 times 8 is. They can focus on learning the procedure, learning the language, because they are working with focus facts. Is there anything you want to add around focus facts?
Yeah. Well, what I'm thinking about is friendly numbers as well. So, if we're introducing, I'll stick with long division. We're not going to have our divisor be a 7 or a 9 right off the bat, but we want to begin dividing with 2s, 10s, or 5s.
Yeah.
So we start, if we're ever introducing a new concept, we always move in gently with the 2s and the 5s. Those are the friendliest facts that our students will usually have. And then we can go into the other facts.
Sure. Yeah. After they're a little more comfortable with that, with the steps and the procedures of that new concept that they just learned, you can expand it and go a little wider. And earlier we talked about using specific language. So this is huge. This is really important for students to use that explicit, consistent, detailed language when you're teaching a new concept. So like Matthew said earlier, like making sure we're using groups of instead of goes into. It's just better language. And so we're going to go beyond defining things and breaking down the parts of a word. So you doing like a morphology, etymology study with words from mathematics is an appropriate activity to do with these kids.
Which we have a lot of those videos online that you've made, Adrianne. So
that's true. That's true. We'll link up to them down below in this video, a bunch of videos for that etymology and morphology, so you can see what we're talking about and how you pair something that they are learning with something they're already familiar with. Like perimeter has the word peri in it, which means around. And so we like to connect it to a periscope that's going around, because that's a wonderful gross motor activity you can do to help provide some meaning, to help them remember that we're going around. It's not just the area space covered. Another verbal accommodation we talked about, and I was going to have Matthew share his camera view again, was with counting with strings and beads.
Yeah, so let's say we're working with our 6 facts. I think these are 6s. Yeah, there we go. So, anytime we can touch and say and see simultaneously, that's a big win. So these strings with wings are just an incredible tool. So one of the things we can do as we skip count is we can begin maybe with the first 3 facts of 6, like this. And so students can see, touch, and say the 6 facts. And we'll see that this is 6, 12, 18. And I will touch and say along with the student on my camera as they say and touch on their camera using their own set of strings with wings. So it's not enough for a student to see me do it. I want them to also touch and say at the same time. So we may practice this for a little while, 6, 12, 18, 6, 12, 18. And then maybe a couple of days later, we'd move into the next 6 facts. So they can see magnitude and quantity. So here's 18, 6, 12, 18, 24, 30, 36. So here's what 36 looks like. And then from here, we would use a number line. So we would move from the concrete to the representational. And then from the number line, we could move to the facts.
Yeah, absolutely.
Yeah.
It's one of our favorite tools because you can so clearly see the groupings. And so you can say things like, if I have 18, how many groups of 6 are in 18?
There you go.
And they visually can see it so fast, right?
Mm-hmm.
It's such an excellent tool. We love this tool. You can learn about it from Marilyn, but also it's in Steve Chin's book, Mathematics for Dyslexics and Dyscalculics. He also likes to use beads. So you can refer to that in that book as well and get some guidance on where to start with those.
Yes, and this is a great tool for improper fractions, mixed numbers. It's just awesome. So there you go.
It's the best. It's one of our favorites that we use. You'll see it being used all the time. So from there, the last one we've got is the semantic, the last ones that we were going to share today. So semantic is accommodations that are focused on supporting the visual spatial aspects of mathematics. So getting your numbers lined up like in the right columns, that is critical because place value matters, right? And then more significant concepts such as place value patterns and number sense and magnitude. We talked about magnitude meaning like how big something is, how small something is. So some of those ideas are a lot more simple than you would think, like limiting how many word problems, not word problems, but just problems in general on the page. We find that more than 4 on an 8.5 by 11 is problematic for a lot of our students. There's not enough space for them to show their thinking and their writing because these kids tend to write big. Wouldn't you agree, Matthew?
Yes, yes.
They write very big. So they need a lot of space. It's like 4 is like the max you would want to put on a page. So think of quarters, teachers, if you were designing a worksheet for a student like that. And then big font as well. They need to see it a lot bigger than you would think. I would say 16, 18 point font would be really helpful, and a simple font too. It's not too fancy. It's just real basic, but you would use. And so those kinds of things really help our students see the quantity, the numbers, and see the lining up of them. And you can use things like graph paper. If you can find graph paper that has bigger boxes, that's really helpful for students to get their alignment correct. But you also can do something as simple as turning a lined piece of paper 90 degrees, and now you've got these columns with blue, right? And that can help with alignment as well. But the other thing we wanted to talk about was like decomposing numbers. And so I was going to have Matthew share his screen again and showing us what do we mean by decomposing numbers?
And I actually had my decimal place value I wanted to show as well.
Yeah, that too.
So I'm going to show that, and
then let's do both.
I'll show some decomposing numbers. So here we go. All right, I was actually working on this today with a student. So what I did is I took a cube of clay, and we divided that cube into 10 pieces, and this is what we got. We got these little slices. So these are our tenths. So a student's able to, where's my flosser? Oh, it's in this hand. So yeah, we sliced the cube up, a clay cube, until we got tenths. And so the student that is now able to see the place value and the magnitude. So they had a cube of clay, and now they have these tenths of clay. And then we begin to read place value like this. So this is 2 tenths. And then we could even write with our marker right here to show. So 2 tenths, this is 3 tenths. And then we took the tenths and we divided them by 10 to get hundredths. And so you can see there the size of a hundredth. So there's 1/100th, 2/100th. And then we can throw the tenths back in there like this. We know that each tenth is 10 hundredths. So this is 22 hundredths.
I love that.
It's a lot of fun to teach, and the kids enjoy it too. So
and I feel like they get it on such a deeper level, right? It repeats that pattern that they remember from place value blocks with the cube, the flat, and the rod, and it keeps repeating even when we're going smaller.
Yeah. And then here's a 7. All right, here. So this is decomposing numbers. So we can show all the ways we can make a 7, and we can build this together. So a 7 can be made out of a 6 plus 1. And it can be made as a 5 plus 2. And we can see that it's always that same quantity broken in different pieces. Be made as a 4 plus 3. So here we are at the concrete stage, and we could do a good bit of decomposing numbers with unifix cubes or these little blocks, and then we could move to dominoes and things like that.
Yeah, absolutely. And what I love about decomposing is that it allows our students to see different ways of using numbers, and they start using them more fluidly in their head instead of always using the counting on strategy or using their fingers and things like that. It's really explicitly teaching them that number sense that they need.
Yeah.
Yeah, so those were just a few. And because of time, we want to respect your time. Matthew and I could nerd out about this all day long. But because of the resource we made this super cool thing together. And Matthew, I'm going to let you to describe the awesomeness that is our accommodations generator.
Wow. The accommodations generator is like this magical machine where you put in where your child may have roadblocks in math and maybe some of their struggles or where they hit the brick wall, so to speak. And you plug that in, you type that in. It's a quick quiz, actually. And after you do the quiz, and I think it takes what, 4 minutes, Adrianne?
Yeah, probably 4 minutes.
Like that. Yeah. And so what the machine does, it gives you a report of accommodations that would help your student, like the ones we're describing today. I think we've touched like 4 or 5 of them today.
Yeah. Yeah.
The accommodations generator, I think has what, I don't know, over 20.
Yeah.
At least. So there are so many. The thing is that there's help available for our students that learn in different ways, and we don't want that help left on the table. We want the students to be able to get the help and the accommodations that really support the way they're wired.
Yeah.
And the way they learn math that makes sense to them.
Absolutely.
So, yeah.
Yeah. And all these accommodations are mostly focused on that input piece, which can be a game changer for a lot of students. So in the report, you'll see short descriptors trying to share what they are. Sometimes there's like a video link where you can go and see what we're talking about for a quick reference for you. But the report will have your name on it, a parent's name, and the student's name. And it's something that you can take with you to that next IEP or 504 meeting and use it to advocate for your child to ask for some of those things. So you can cruise through that document. It spits out, I don't know, about 10 pages. And you could highlight some of them that you'd like to attempt to add to that IEP in 504. So we'll link to it down below here. And feel free to share it with your friends. We think it's a really valuable tool that will get a lot of use. And we'll make adjustments as things change or as we learn new things. But we'll adjust our reports and make those changes as well. But we're just excited to share it with you all. And yeah, just run and go take it right now. It's free, doesn't cost you anything. We just wanted to give better support to not only the parents, but even teachers could go and put in a student that they know is struggling and get some very real ideas on how to support that particular student.
Yeah, that's right.
Okay. All right. So Matthew, we always end with a math joke. So let's do that now. Let me share the screen. I'm going to share this one. And as usual, this is always my disclaimer. I didn't say they were going to be good. Why did you eat 9? My doctor said I needed 3 squared meals a day.
Oh.
That's terrible. 3 squared meals a day.
Love it.
But I love it. So thanks to Tim, the right triangle, for always making just nerdiness for us. Thanks, we really Tim. Love it. All right. We'll see you guys again soon.
All right. Bye, y'all.